Hey everyone, it's Jay. I'm here on a beautiful fall day to have a look at a cross-section of the spinal cord. If you haven't had a look at the video on spinal nerves, it's worth doing so. If humans are going to function in the world, we have to sense and respond to changes in our peripheral tissues. An example is this stretch reflex, where if the patellar ligament is stretched unexpectedly, my muscles contract to counteract that stretch. The reflex is processed in the spinal cord, and the signal doesn't have to go to the brain for the reflex to happen. On the other hand, I become aware of being hit with a reflex hammer, and that awareness occurs in the brain, so signals of being hit have to travel through the spinal cord to the brain for me to know what's happening. The spinal cord is part of the central nervous system that's responsible for processing and transmitting signals that travel through spinal nerves. The spinal cord is made up of gray matter and white matter. Signal processing happens in the gray matter, which is made up of cell bodies, dendrites, and unmyelinated axons. This is where presynaptic neurons determine whether or not an action potential is fired in a postsynaptic neuron. The white matter is made up of myelinated axons, so signals are transmitted through white matter, but we don't see signal processing. The spinal cord can be divided into 31 segments, and each segment is associated with a spinal nerve. When we look at the cross-section, you can see gray matter that looks roughly like a butterfly, surrounded by white matter. The gray matter on both the left and right sides has a posterior gray horn, lateral horn, and anterior horn. Between the horns, we see a structure called the gray commissure and a central canal, which is filled with cerebrospinal fluid. The white matter can be divided into a posterior column, lateral column, and anterior column. You may hear a white column referred to as a funiculus. That's a crude summary of the gray and white matter in the spinal cord, but if we want to look at specific pathways, we have to be more specific. The posterior gray horn of the spinal cord houses the cell bodies of sensory neurons. The most posterior part of the horn houses the somatosensory neurons, and a little closer to the central canal, we see cell bodies for visceral sensory neurons. Somatosensory refers to signals like mechanical and painful signals that often come from the skin, muscles, bones, and joints. Visceral sensory refers to signals from internal organs. The anterior gray horn of the spinal cord is home to the cell bodies of lower motor neurons, so this is where excitatory and inhibitory signals determine whether or not we contract a skeletal muscle. The lateral gray matter of the spinal cord houses the cell bodies for autonomic neurons that control the activity of smooth muscle and glands. The lateral matter is mostly associated with the sympathetic nervous system, so we see the lateral gray horn at spinal segments T1 to L2. There's some lateral gray matter associated with the parasympathetic nervous system, and we see that at segments S2 to S4. White matter in the spinal cord is made up of myelinated axons, and this is a site of signal transmission. White matter is separated into groups of axons called tracts, and each tract carries a similar type of information. Broadly, we can separate these into ascending and descending tracts, where ascending tracts carry sensory information to the brain, and descending tracts carry motor information away from the brain. Examples of ascending tracts are the lateral spinothalamic tract, which carries signals of temperature and pain to the brain, versus the anterior spinothalamic tract that will carry signals for crude touch. If we're interested in the route taken by signals for fine touch, those travel through the dorsal column. Descending tracts carry motor information from the brain to lower motor neurons in the anterior gray horn of the spinal cord or the lateral gray matter. For example, if I want to contract my biceps brachii, a signal will travel down a tract like the lateral corticospinal tract to synapse on a lower motor neuron that has a cell body in the anterior gray horn of the spinal cord. All right, quick summary. The spinal cord is responsible for processing and transmitting signals that travel through spinal nerves. The spinal cord is made up of gray matter and white matter. The gray matter has a posterior horn that houses cell bodies for sensory neurons, an anterior gray horn that houses the cell bodies for somatic motor neurons, and lateral gray matter that houses the cell bodies involved in autonomic signaling. The white matter is divided into tracts of axons that carry similar types of information. Ascending tracts carry sensory information toward the brain, and descending tracts carry motor information away from the brain. If we understand the organization of tissue in the spinal cord, we can begin to dig into specific pathways and describe how humans navigate as we move around in this beautiful world.